All right, folks, greetings again. So this is going to be the first in a series of videos and lessons that I'll be doing with this whole distance learning thing going on. First one we're going to talk about is going to be doing some operations on rational expressions. As we get into these, it's a really good idea to have some paper and a pen or pencil nearby so you can kind of practice the things we're going to be talking about. I'm going to encourage you to pause the video a couple times to work on a problem before we go through the answer and things like that. So if you need to take just 1 second and get some paper and pencil, please go ahead and do that. So just before we get into the operations, let's talk about what a rational function is from before spring break and all this stuff started going crazy. So remember, our parent function is just the function 1 over x. Most of the functions that we dealt with have some kind of polynomial in the numerator, a different polynomial in the bottom, and we did some analysis of those things to find the different attributes. Remember, a lot of times we had to factor the top and the bottom before we started doing the analysis, so make sure you remember how to do the factoring. We found the vertical asymptotes. And as I go through these, again, think to yourself, do you remember how to do this before I show you what it is? So how do we find the vertical asymptotes? Well, we had to set the denominator equal to 0 and solve it. How about the x-intercepts? For the x-intercepts, we had to set the numerator equal to 0 and then solve that. And remember that there could be more than one of both of those, the vertical asymptotes or the x-intercepts. How about the y-intercept? There can only be one of those, there may be none, but the way we do that, we plug in 0 for all of the x values. And then the whole, also called a removable discontinuity. If there's one of those, when did we see that happened? Well, that was whenever, once we factored it, if they factor canceled out at the top and the bottom, that thing that canceled, you set that equals 0 and solve that, and that was the x-coordinate of a hole that existed. Now remember, for the horizontal asymptotes, that's where there were some different cases going on there. So there are 2 different cases if there's a horizontal asymptote. One of them was when it was bottom heavy, and that was automatically going to be y equals 0. And the other case was when it was equal, and that was that horizontal asymptote there would be when it was y equal to the ratio of the leading coefficients. And remember, when we're talking about bottom heavy and equal, or the top heavy, which we're going to get to in just 1 second, we're talking about the biggest power in the numerator or the denominator. Okay. So then that third case, as I said a second ago, is the top heavy case. And remember, if it's top heavy, there is no horizontal asymptote, there's only a slant. And we would find the equation for that slant asymptote by doing division, either long or synthetic, whichever one we want to do. Okay, so we're not going to get into those kind of questions. We did those before break. We've already had a test on those. And we're going to move on into operations. So what we're going to be doing, so today we're going to be doing multiplying and dividing. And we're going to have some where they're already factored. We'll have some where we have to factor them, but the questions are going to look basically like this. And then in a couple of days, there'll be another video on adding and subtracting that'll look like that. Okay, so we're going to jump right in here and start doing some multiplying. Okay, we're going to start off with factored form, a little bit easier. Now, you already know how to factor, but we've kind of already factored some of these for you, and you'll see some of both of these on your assignment in the practice we're going to have you do. So take a look at this. So here's our first question. So do me a favor, pause the video for just a few seconds. And even before I tell you how to do it, I want you to think about, what do you think it is? Just take a stab in the dark and see what you think you would do here. So go and pause the video, and then we'll go through what happens. So you might have seen that you can cancel some things out. So remember, anytime we have a like term on the top and the bottom, then those terms will cancel out. So you see we have the x plus 5 on the top and the bottom. And even though they're in different fractions, they're in different places, one's on top, one's on the bottom, it's okay, they cancel out. And there's also an x plus 1 that they have in common, so those guys go away too. Nothing else cancels. So we're just going to write down what's left over. And we have that, and you're done. That is your answer, okay? And that is 100% acceptable as a final answer. If you want to get kind of frisky with it, you can multiply out the top, using box method or FOIL or whatever, and do the same thing on the bottom. So on the bottom of the screen there, either one of those is okay. I'm totally okay with not multiplying it and leaving it in factor form. It's completely up to you, personal choice. Okay, so every single time, that's what we do. So if it's already in factor form, we look and see, cancel out like terms, and go from there. So here's the next one we're going to do, and I really want, so definitely pause the video here, write down that question on your paper, and see what you come up with. See if you can do that one on your own. Now remember, there are some leading coefficients on each of those fractions. Those can usually be simplified also. Okay, so see what you come up with. I'll give you a few seconds to pause the video, and then we'll go through the answer. Okay, so again, what happens? So I've got some like terms that I can cancel out. And also notice the leading coefficients, and I kind of highlighted them in red there. So if you see here, the 15 over 12, I can divide both of those by 3 and get 5 over 4. And I got the 30 over 40, and I can divide both of those by 10 and get 3 over 4. And then I can cancel some things out, the x plus 3s and the x plus 2s. Once we're done with all that stuff, then we can just write the final answer. So 5 times 3, that's where the 15 comes from. 4 times 4 is a 16, and then again, just leave in factor form, and that's your final answer. Okay. So moving on now, how about dividing? So it's almost the same thing. In fact, we're going to turn it into multiplying, but let's do a quick review of just how do we divide fractions in the first place. Let's go back to your elementary school days. So how would you do these two problems? And if you remember, some of your teachers might have used the term keep, change, flip. So again, I'm going to give you a second, pause the video, see if you remember how to do that. Don't use a calculator, and see if you can work those out by hand. Well, the first one here, again, keep, change, flip. What does that mean? That means we're going to keep the first fraction, so 2/3 stays the same. We're going to change the division to multiplying, and then we're going to flip the second fraction to 15 over 8. Now, this one's, we don't have to do any simplifying here, at least right off the bat. We can just multiply straight across. So 2 times 15 is 30, 3 times 8, 24, and then we can simplify that from there. So I can divide both of those by 6, and you get 5 over 4. Now, the second one, and if you want to pause the video again, if you didn't quite get that the first time, you want to pause it here, try to do the second one on your own, you can go and do that. But we're going to do the exact same thing. Keep the first, change the multiplying, flip the second, so it's going to become this one. Now you're looking at that going, hold, wait a minute, 9 times 36, 16 times 27, those are some big numbers. So we can we can cheat a little bit. Not cheat, but we can simplify this without multiplying straight across and getting those big numbers. Notice I kind of color coded them here. I can say 9 over 27 because one's on top, one's on the bottom, so that just becomes 1 over 3. And then the 36 over 16, well, I can divide both of those by 4, so that becomes 9 over 4. That's much more manageable. So now if I just go straight across, I get 9 over 12, which is just 3/4, and that's your final answer. Okay? So we're going to use that same exact process when we're dividing rational expressions. We're still going to do the keep, change, flip thing, so cancel things out, and then see what's left over. Okay, so let's do a couple of these things. So here's your first one. So again, it's already in factored form, so we don't have to do anything extra here. So we're going to start off, keep, change, flip. Okay, keep the first, change it to multiply, flip the second. So it's going to end up looking like this. Okay, first one stayed the same, multiply, flip the second one. And now we just start canceling things out. Anything that's in common on the top and bottom. So I have an x plus 2 on the top and bottom. I have an x minus 8 on the top and bottom. And I have an x plus 6 on the top and bottom. So a lot of things go away. And then write what's left over, which is just the x minus 4 and the x plus 1. And that's it. You're done. Let's take a look at one more. So again, I'm going to have you do this one on your own. Here's the question. Pause the video, please, please. Write down the question and see what you come up with. And we'll start going through the answer in just about 5 seconds. Okay, so I just gave myself a little more room here. So there's the question. Again, first things first, keep, change, flip. Whole first term stays the same, multiplying, flip it. And again, here, it's got some leading coefficients here. So I can simplify those guys and then cancel out some like terms. So I color coded these guys. I canceled out the x minus 10s, canceled out the x plus 1s. But the 5 and 25, I can simplify that fraction. Same with the 24 over 12. Again, anything on the top and bottom, you can simplify or cancel. So this now becomes 1, because 5 over 25 is equal to 1 over 5. Still has the x there for the x plus 2. And then the 24 over 12 becomes 2 over 1. And that's where the rest of that comes from. And now I can just multiply straight across and write down what's left over. So it'd be 2x to the third. Notice the exponent, x times x to the second is x to the third power. And down the bottom, you just have 5, and then the 2 factors of the cancel. And that's your final answer. You can leave it like that as just fine. Okay, now we're going to give you some problems that are in factored form. Sometimes you may not have factored form. Sometimes you may see questions like this where you have to do the factor. Okay, and we've been factoring for a long time now, so it shouldn't be a surprise to you that this was coming. So again, last time, please pause the video here. See if you can do both of these things. Notice on the left is the multiplication, on the right is division. I'll give you about 5 seconds to pause the video, and then we're going to run through the solutions so you can check your work fairly quickly. Okay, so on the left, again, nothing crazy here. All we got to do is factor it. So on the denominator of the first fraction, x squared minus 9x plus 20, that factors x minus 4, x minus 5. On the second fraction, there's just a GCF here. We can take a GCF of 5 out, leaving us with that. Cancel out what we have in common. And notice that 5 over 15 can be simplified to 1 over 3. So we have 6 times 1, and then x minus 4 times 3. I can just rearrange that a little bit. And actually, I could do this one more time. I could simplify the 6 over 3 to be 2 over x minus 4. Would actually be your final answer. I just didn't quite have room to type that in there. Now for the right-hand side, this is a division question. Now to save space here a little bit, just to warn you before I go over the next screen, I did the keep, change, flip, and the factoring at one time. So here is the first fraction. So again, keep it the way it was, factor out the GCF, change to multiplication, and then I flipped, and I kind of color coded them just to make sure you see where everything is. And then from here, I can cancel things out. The x minus 4's cancel, and the x plus 3's cancels. And then we just write down what's left over. So we have the n+2 times n+4 all over 16. And that is multiplying and dividing. So at this point, look for some practice problems, probably 5 or 6 practice questions on multiplying and dividing. Those will be posted on Classroom along with this video. Please complete those on your own piece of paper and submit those through Classroom, and I'll put directions on how to submit those in the assignment. In a couple days, I'll be putting a video up on adding and subtracting in this similar kind of format here. If you have questions, email your teacher, log into Google Meet. If you're one of my students, I'll put the link to Google Meet on Classroom. You can reach me there 8:30 to 4:30, Monday through Friday. You can email me anytime. And you know, feel free to share the video if you have some friends that are in altitude or doing the same kind of stuff elsewhere. Feel free to share the video, subscribe, so you can just kind of get notifications when these things come up. Okay. Thanks for your time. Hope you found this video informative and useful. And we will see you next time. Keep studying.